Good evening, everyone. My name is Mbavazi Elizabeth Shelley, a student at Makerere University, taking a master's in computer science, and this is one of the modules, machine learning. And I'm here to talk about linear regression, some linear regression algorithms or techniques used in machine learning. These that I'm going to talk about were in a paper I reviewed, and the paper is titled Linear Regression Android, which is that short form of Linear Regression, detection of Android malware using multiple linear regression models, based classifiers. So in summary, the summary of the paper. In summary, so this paper is talking about malware in Android applications. Basically, we know that these days most of the phones or mobile devices, especially phones that are being used, are using Android operating system. And this has been taken up by many developers because it's an open source, it's an open source operating system, and someone or the developer can actually make change to Android, and you can also be able to add more applications apart from those that it comes with. And yes, so it has been taken up by most of us or most of the people in the world, and they can use it we do use them to share information. We can actually, people using their devices to, share information via emails, confidential information that is. We are also using it to, do bank transactions based on the applications on our phones, and etc., which wasn't, in those days where we just send a message, maybe saying hello to a friend. So being used for that these days, also people were developing malware are not relaxing, and information is, the new currency one of these days, and people are developing malware and using it to attack people and take on their things and steal their information. So therefore, the need to come up with malware detecting algorithms. Malware detection algorithm. This is so this brings up the need to develop or to come up with ideas that can be able to detect malware in Android applications. And yes, this detection was done using different permissions that are embedded in the Android applications that are built, because that's where the malware is actually carried. And in case you give this application maybe a certain permission, it could be having access to your audio, photos, videos, etc. And this application has malware in it, then the hacker or whoever owns it can be able to have access to that information and do with it as they wish. So we are going to look into the solution that was developed and how it is relating to my project that I'm actually doing currently. And my project is forecasting or detecting crime in different locations in Uganda. So the first one was linear regression. We're talking about the linear regression classifiers. Under linear regression classifiers, we have one, and then we have maybe let me call it singular regression classifier, where we have one dependent variable and one independent variable. And this is the equation here. So when you look at this, y is called the dependent variable and x is the independent variable. The point where the line intersects the y-axis and the x-axis is B, this B here, and B1 represents the regression coefficient, this, and E represents the error of the obtained estimate. And then in case it happens that you have multiple independent variables, then you do use this equation here, which shows, y is the independent variable, and then B, and then the error as just as similar to this one here. And then the way linear regression, because this was used to further classify, the information and to be able to tell which application has malware and how best to, classify them and tell. So linear regression draws like a baseline of fit after you've trained the model and it begins to predict and give results. It draws a baseline of fit where it clearly separates, and the error helps to show whether this one falls under this or that. So it clearly separates which feature falls under a certain category. So in my project, we're working on predicting a given crime or forecasting crime in a given location. So in this case, we want to know which locations are prone or at a high chance of this crime happening there, and how often does it happen there. So linear regression helps us to classify and show which particular locations that have a high crime rate, and how often do these crimes happen there. Yes. And then we have next is what they use is the bagging of the best classifiers. Now, bagging basically means you have your data set and then you divide it into subsets of the data set. Like you get the training data set, there is the testing, validation, etc. So now the training data set, you divide it into several data sets. They could be 3, 2, depending on what you want, 4. And then you do train the model using a subset. If there are 5, you use a fifth, the first subset of the data set, and you train it. So after you train the model, you generate you train the model. In this case, let me say we use decision trees. So you have a decision tree from a particular data set and with a particular model. So then you do the second data set, you also train it, get its decision tree, you do the same for the third data set, and it is it. So this is bagging is an assemble technique. So after that, you will have several decision trees of each data set that you've trained here. So now to get like the best classification, to show the best classification in this case, all those trees are going to be combined into something we call the random forest decision tree. So in this case, the random forest decision tree is one that is going to classify for us the different data. So because after you have the decision trees, it's going to go into converging and trying to know where each lies. So say you have 3 different data sets, and maybe one predicts that, yes, in my case, in my project, one predicts that the first data set shows that there is a high crime in this particular location. The second data set again shows that, yes, in this particular location there is crime. And then the third data set shows in this particular location there is no crime. So since 2 of them are showing us that there is crime in this particular location, that means our forest after bagging or combining these models, our random forest decision tree is automatically going to show us that in this particular location, there is crime that is most likely to happen there. So yes, these were the techniques used in the paper that I reviewed. Most of them, there were also other techniques like SVM, naive Bayes, but we've done research on this before and talked about them before. So I just wanted to really talk about these ones that I haven't talked about, and like a bit specific also, since like, it's linear regression. Yeah. And yes, why they chose the random forest decision trees, because it's best for the ensemble technique, to use it in the ensemble technique, which is bagging. So when you look at the word ensemble, it's basically like, combination of different things. And yes, these are the references. This is the reference to the linear regression paper that I reviewed. You can go and read through to further understand the solution that was developed. Thank you so much for your time, and I hope you learned something. Yes, comments are welcome. Criticism, and thank you for listening.